Okay, chapter 3.1, this is going to be quadratic functions. So a quadratic function is just a polynomial function which has the highest degree of 2, meaning the largest variable exponent is 2. So there's going to be two different forms that we're going to be seeing these in. There's going to be general form and standard form. So general form is going to look something like this. It's going to be f of x equals ax squared plus bx plus c. So a, b, and c here are constants, and you can see that the highest, the largest exponent is a 2 on the variable x. Standard form is going to be f of x equals a times x minus h squared plus k. So here the a, h, and k are constants, and you can see it's kind of in this factored form with the x minus h, that binomial squared. Okay, so those are going to be the two forms that we're going to be seeing these in primarily. So going over some properties of these functions, these are going to be parabolic shaped, meaning that they're going to be parabolas. So they kind of look like U's. If this a in either the general form or standard form, if that's positive, that means the graph, that U shape, the parabola, is opening upwards, meaning it's going to have a minimum value. If it's negative, it's going to be opening downwards, having a maximum value. And that coordinate, that turning point, is called the vertex. So vertex. And there's going to be symmetry. There's going to be symmetry at the vertical line through the vertex. So it's going to be x equals whatever the x coordinate of the vertex is. That's going to be your symmetry. So let's see some examples here just to see what these look like. So let's say we have a quadratic and the a is positive, meaning it opens up. It's up a little bit. And let's say it looks something like this. Right, so that's the parabola, so it kind of looks like a U. We have this point right here as the vertex. And the axis of symmetry would be this right here, so it should be symmetric over this line. So it's a vertical line, so the equation for it's going to be x equals, in this case, 2. So it's the x coordinate. Let's say we had a is less than 0, so that the a value is negative, and that means it's opening downwards. So that means it would look something like this. So something like that, opening downwards. And we can see, once again, the vertex is right here. And then we have this axis of symmetry right here. In this case, it would be x equals negative 3. Okay, so those are just two examples of what they might look like. It's also important to know that that vertex is it's a rounded turning point. It's not a sharp turn, it's a rounded turning point. Okay, before we start graphing these, let's just talk about the basic quadratic function real quick. So the basic quadratic function is essentially the parent quadratic function, whatever you want to call it, same thing. It's just kind of the most basic version of a quadratic. So this is going to be the quadratic f of x equals x squared. So coefficient of x squared coefficient of 1 on the x squared term, and there's no x term, and there's also no constant term. So let's graph this and see what it looks like. So let's plug in some points for x. I'm going to plug in negative 3, the integers negative 3 to positive 3. So f of negative 3 is going to be negative 3 squared, which is negative 3 times negative 3, so 9. Negative 2 squared is 4, negative 1 squared 1, 0 squared is 0, 1 squared 1, 2 squared 4, and 3 squared 9. So these are going to give us some xy coordinates. So for the first one, we get the xy coordinate negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So let's graph this and see what it looks like. So it's going to be negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So we're going to connect these with a smooth curve. Try to make it look smooth and rounded, not just connecting each dot with a line. Okay, so that's going to be our basic quadratic function. So you can see just by looking at it that the vertex is at 0, 0, which would make the axis of symmetry x equals 0 for this basic quadratic function. All right, so now let's get into graphing them in these two different forms. So let's start with standard form. So here are kind of some of the important properties for standard form and how we're going to be graphing them. So quadratics in standard form, so recall that in standard form, this is standard form from the previous page. So the vertex in standard form is going to be just h comma k. It's the coordinate, the xy coordinate h comma k. So this comes down to the transformations of functions. When we were going back up here real quick to the basic function, the vertex is at 0, 0. This little x minus the minus h here, that means we're moving it horizontally h units. So we move the vertex h units, the x coordinate for the vertex h units. And then this k value is the vertical shift, meaning we move the y coordinate for the vertex, which was also 0. We moved that k units to that new k value. So it's just as easy as looking at the function to find the vertex when it's in standard form. So this makes the axis of symmetry x equals whatever that x coordinate is, x equals h in this case. And as always, a is positive, it opens upwards, a negative opens downwards. So the steps for doing this, it's going to be pretty much the same steps every time. We're going to determine if it opens upwards or downwards by looking at the a value. We're going to determine the vertex, find the x-intercepts, if any, by setting the function equal to 0 and solving for x. So for the x-intercepts for quadratics, there's either going to be none, there's going to be 1, or there will be 2. Those are the only options. And then we're going to find the y-intercept by evaluating f of 0, so setting x equal to 0, and then evaluating f of 0. We're going to plot those points, and then just connect them with a smooth parabolic curve. So let's see this example here. So for the first one, we have f of x equals negative 2 times x minus 3 squared plus 8. So this is in standard form. So first, let's do the, if it opens up or down. So for that, we're looking at this a value out front, which is negative 2. So a is negative, so that means this opens down. It's pretty easy. For the next one, let's find this vertex. So the vertex is going to be the h comma k. So our h is 3 and our k is 8. So just don't get confused here and say negative 3 by accident. It's x minus h and it's x minus 3 here. So it's always the opposite plus or minus sign from what you see inside those parentheses for the x value. And then the y value is the same plus or minus sign from what you see. Okay, and then the x-intercepts. So the x-intercepts, this is going to be setting the function equal to 0. So we set f of x equal to 0. So that's going to be negative 2 times x minus 3 squared plus 8 equals 0. So these ones are going to involve using the square root property. So we're going to solve for that x minus 3 squared term, and then we're going to square root both sides. So I'm going to subtract 8 on both sides. So subtracting 8 on both sides gives us this. We get negative 8 on the right. Divide both sides by negative 2. cancels on the left, and on the right, negative 8 divided by negative 2 gives us 4. And now we square root both sides. So something to remember here, when we square root both sides like this with an equation, we're going to get plus or minus the square root. So square root of the left side cancels the squared, which is the whole point of doing it. And then we get plus or minus the square root of 4. Okay, and then so that'll happen every single time. So that square root of 4 is just 2, so plus or minus 2. We're going to add 3 to both sides. We get x equals 3 plus or minus 2. So obviously don't leave it like that in this case because we can just evaluate those and we need them to be able to graph it anyway, separately. So when we do this separately, we get x equals 3 minus 2, or we get x equals 3 plus 2. So we get x equals 1 or x equals 5. You can put an and instead of an or, but it doesn't matter. So we get 1 and 5 for our x-intercepts. Go up here for some room. Let's find these y-intercepts. Or y-intercept, rather, just one of them. So to do this, we evaluate f of 0. So we know there's always going to be one y-intercept because these functions are going to be continuous functions. So they have to cross the y-axis, and we know it's only going to cross it once, because if it crossed it more than once, it would fail the vertical line test, making it not a function. And these are functions. So we're going to plug in 0 into the original, into x. So it's going to be negative 2 times 0 minus 3 squared plus 8. So negative 2 times negative 3 squared plus 8. So just don't screw up your order of operations here. That's negative 2 times 9 plus 8 after you squared that negative 3. Negative 2 times 9, negative 18, plus the 8 is negative 10. So that is our y-intercept. So let's graph all these points now. So we have the vertex was 3, 8. So 3, 8. The x-intercepts were 1 and 5. Y-intercept was negative 10. Okay, so there is enough here to graph it. Obviously, you can tell that it opens down based on just looking at it. And we know it opens down from that first step that we did. I'm going to put another point here. I'm going to put a point right here just to help us graph it a little bit. And maybe you can see how I did it and why I put it there. So I put it there based on the symmetry. So I use that y-intercept of negative 10, knowing there's going to be another negative 10 right over here. And just once again, it's based on symmetry, just to help you graph it. Okay, and then kind of the hard part, connecting them with a smooth continuous curve and just try not to mess up. Okay, and there's our function that is f of x. Okay, so it opens downwards, meaning we have a maximum value right here at the vertex. So no point is greater than that on the whole entire graph. And the axis of symmetry here would be x equals 3. Okay, let's do 2 more for standard form, just so we can see kind of all the different cases for how these are going to look. Okay, so for the next one, we have g of x equals 3 times x plus 1 squared. So step 1, let's see if it opens up or down. So we have to look at this a, which is 3. So a is positive, so this means it opens up. Next, let's find the vertex. Once again, pretty easy for standard form, finding the vertex. No real calculation involved. We're just kind of looking at it. So the h here is going to be negative 1, so it's the opposite of what you see, plus or minus sign. And there is nothing afterwards, so it's just plus 0, so that means the y-coordinate for the vertex is just 0. And then next for the x-intercepts, we're going to set our function, which in this case is just called g of x. set that equal to 0. So we're going to set 3 times x plus 1 squared equal to 0. So solve that for that binomial squared. So divide both sides by 3. It cancels it on the left. And on the right-hand side, 0 divided by 3 is 0. We're going to square root both sides. When we square root both sides, the square root of 0, or plus or minus the square root of 0, is just going to be 0. Subtract 1 on each side, we get x equals negative 1. So this time we get just one x-intercept, which is fine. Okay, and then step 4, we're going to find the y-intercept by evaluating g of 0. So what was our function again? 3x plus 1 squared. So we're going to plug in a 0, so 0 plus 1 squared. That's going to be just 3 times 1 squared, which is just 3. So that's our y-intercept. So let's plot these points. So we have our vertex, x-intercept, and the y-intercept. So the vertex was negative 1, comma 0. The y-intercept was 0, comma 3. And we know that it opens upwards. So it doesn't seem, we only have 2 points plotted here. It doesn't seem like we have a lot, but this is actually enough to graph it. So we know that it's opening up, and we know that that's the vertex at negative 1, comma 0. I'm going to use that y-intercept to help us plot another point. Based on the symmetry, we know that this has to also be a point. Okay, and then just going to connect them and say good enough, and that is g of x. So this one is opening upward. So it has a minimum value at the vertex. And the axis of symmetry would be x equals negative 1. Okay, let's do one more for standard form. So we have h of x equals negative x minus 2 squared minus 3. So once again, let's do the same steps. So opens up or down. Hopefully it's starting to get a little bit repetitive. So our a here is negative 1. Our a is negative, so it opens down. So step 2, vertex, h comma k, standard form. So the vertex here is going to be based on this value and this value. So it's going to be positive 2, so opposite sign from what you see, and then negative 3 for the y-coordinate. And then next for the x-intercepts. So we're going to take the function, which was h of x this time, and we're going to set it equal to 0. So what was this function? Negative x minus 2 squared minus 3. So we're setting this whole thing equal to 0. So we're going to add 3 on both sides. And we get this. And then we're going to divide or multiply both sides by a negative 1 to cancel that negative out front. So we get x minus 2 squared equals negative 3. And then we're going to square root both sides. So when we square root both sides here, we get x minus 2 equals plus or minus the square root of negative 3. So this square root of the negative, if you remember, that's going to give us imaginary numbers. So since those are imaginary numbers and we're on the real xy plane here, there's going to be no x-intercepts. Okay, so no x-intercepts because of the square root of the negative. The negative is in that radicand, so no x-intercepts. Okay, and for the last thing, we need the y-intercept, so we need to evaluate h of 0. So plug in a 0 for x, we get negative 0 minus 2 squared minus 3. So we get negative 2 squared minus 3. Negative 2 squared is positive 4, but we have the negative out front, meaning negative 4. So negative 4 minus 3 gives us negative 7. That's our y-intercept. So let's plot everything, see what we have. We found that the vertex was, 2, negative 3. So right over here. The y-intercept was negative 7. No x-intercept, and we know that this opens downwards. So we can fill in this point right here to help us. So once again, use that y-intercept, same y value. And this was 2 x values away from the vertex, so that means this one has to also, based on symmetry. Okay, and connect them, and there we go. That is our parabola h of x. All right, so that is standard form. Hopefully that wasn't too awful, pretty repetitive. So next for general form. So graphing these in general form, so recall from that first page, general form is when it's in the form f of x equals ax squared plus bx plus c. So it's expanded out for us. So it's a little bit harder here. The vertex, when it's in standard form, is going to be, we actually have to calculate it. The x-coordinate is going to be negative b over 2a. So we have to use the b value, use the a value, and calculate the x-coordinate for the vertex. Once we find that value, to find the y-coordinate, we just plug that x-coordinate back into the function. So that's what this f of negative b over 2a means for the y-coordinate. So a little bit more work for the y-coordinate, or for the vertex, for general form. So the axis of symmetry is just once again going to be x equals the x-coordinate, and just like before, positive a value, it's opening upwards, negative a value opening downwards. So here's how we're going to be graphing these. Pretty much the same steps, going to do a couple of them a little bit differently. So we're going to determine if it opens up or down. We're going to find the vertex. We're going to find the x-intercepts once again by setting the function equal to 0 and solving for x. This time we're going to have a couple different ways of solving it. We're either going to use factoring and the zero product property, or the square root property, or the quadratic formula. So the quadratic formula will always work, but the other ways might be a little bit easier, if you can do them. So the quadratic formula, hopefully we kind of know this by now, but if not, it's right here. It's the solutions for a quadratic in general form are going to be x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So a little bit of a calculation, not awful. So once we find that, then we can find the y-intercept by evaluating f of 0. This is going to be very simple because, as we'll see, let me scroll back up now. When it's in general form, when you plug in a 0, the only term that's going to be left is the constant term at the end, so that's always going to be your y-intercept. We're going to plot all those points lastly and just connect them with a smooth curve again. So let's do a couple examples of these. So for the first one, let's graph x squared minus x minus 6. And we're going to be doing the same steps here. So this is obviously in general form because it's expanded out. So our a value is 1. It's 1x squared because there's nothing written. The coefficient's 1. So a is positive, so this opens up. Okay, and then next for the vertex, once again, it's going to be a little bit more work. It's not going to be awful. The vertex is going to be negative b over 2a, comma, the function evaluated at whatever the heck that is. I'll do this as side work. So negative b over 2a is going to be, so our b is negative 1. So negative 1 over 2 times a is 1. So this is going to give us 1 over 2, so 1/2. So to find, that's the x coordinate. To find the y coordinate, we're going to have to plug in 1/2 and evaluate it. So it's going to be 1/2 squared minus 1/2 minus 6. Okay, so 1/2 squared is 1/4. 1/4 minus 1/2 minus 6. So let's do this by hand instead of using a calculator. Let's just make sure we remember how to add and subtract fractions here. So common denominators of 4 be 1/4 minus 2/4 minus 24 over 4. Okay, so just got common denominators. So 1 minus 2 is -1. -1 minus 24 is -25. So -25 over 4. So -25 over 4, you can write this as a mixed number if you want, or use your calculator. Preferably be able to write this as a mixed number, just so you can figure it out as a decimal. It would be -6.25. So a little messy, but that's okay. So that's going to be, the vertex is the coordinate 1/2 comma -6.25. Not ideal, but that should be fine. Okay, and then for the x-intercepts, we're going to take the function and set it equal to 0. Function was called f of x again. So we're going to set it equal to 0. And what was the function? X squared minus x minus 6. Okay, so it's a quadratic, and it's a quadratic equation. So typically you want to get everything on one side of the equation, which it already is, set equal to 0. Try to factor it. So you hope that it factors because it's a little bit easier if it factors. If it doesn't factor, you probably should just use the quadratic formula. So this does factor. Two numbers that multiply to -6 that add to -1 are -3 and +2. So we factor it as x minus 3 times x plus 2. So this is going to be the zero product property. So either you can skip right to the answer or actually set it up like I'm setting it up right here just to make sure that we know how to do it. So if something times something equals 0, one of those somethings has to be 0, one of those factors has to be 0. So we set them equal to 0 separately. So x minus 3 equals 0 will give us x equals 3, and x plus 2 equals 0 will give us x equals -2. So those are our x-intercepts. So a little bit easier than the quadratic formula. So lastly, we need the y-intercept. And it's going to be same as before, evaluate f of 0. So we're going to plug a 0 in. So it's going to be 0 squared minus 0 minus 6. So you can see here how everything cancels except for that last term. So it's just -6 is our y-intercept. Okay, so let's plot everything. So we have a vertex 1/2 -6.25. So 1/2 -6, 1, 2, 3, 4, 5, 6. So about right here. The y-intercept is -6. So right next to it, which makes sense. And the x-intercepts 3 and -2. So here's x equals 3. Here's x equals -2. And looks pretty good. Then we can graph it. So connect those, and that is our function. That is f of x. So it opens up, which we also verified in that first step, and it has a minimum value at the vertex. So the equation of the vertex would be negative, or rather x equals positive 1/2. Okay, so let's see this next one. Next example, we have g of x equals negative x squared minus 2x plus 1. Okay, so for this one, we are going to see if it opens up or down. The a value here is out front once again, so it's -1, so it's negative. So it opens down. Okay, and then next, for the vertex, once again, general form, we have to calculate it, negative b over 2a, and then the function evaluated at the x coordinate to find the y coordinate. So negative b over 2a, b here is -2, so it's -2 over 2 times a is -1. That's going to be 2 over positive 2 over -2 gives us a -1 for the x coordinate. So we're going to evaluate this y coordinate. So it's going to be g of the x coordinate. So we're going to plug that in, -1 squared minus 2 times -1 plus 1. So if we evaluate this, -1 squared is +1, but we have the negative out front, making it negative. So it's going to be -1 plus 2 plus 1 is going to give us 2. So once again, just don't mess up your order of operations. That gives us a vertex of -1, 2. Next, for the x-intercepts, so we're going to take our function and set it equal to 0. So we're going to have, what was our function here? -x squared minus 2x plus 1 equals 0. Yep. Okay, so we might try to factor this one. Maybe get everything on the other side of the equation so the x squared is positive, but this actually does not factor. So let's just skip right to the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2 times a. So our a is -1, our b is -2, and our c is 1. So let's plug all of these in. So it's going to be -2 plus or minus the square root -2 squared minus 4 times -1 times 1 all over 2 times a, which is -1. So definitely use parentheses. It'll hopefully make it so you don't make a silly mistake. And a little bit of a hint here, a little bit of a tip, that b squared is always going to be positive, because when you square something, it's always positive. So just kind of keep that in mind to make sure you don't accidentally have a negative value after you do that b squared. Okay, so if we went through and we evaluated this, we end up getting 2 plus or minus that discriminant. So the radicand, what's under the radical, is called the discriminant here. We'd end up getting +8 and then -2 in the denominator. So we could simplify that square root of 8 and make it 2 radical 2 and then cancel off factors of 2, but I'm just going to leave it like that for now. We want an actual decimal answer for this so we know where to graph it, unless you know where to graph that right now. If we plug this into our calculator and did 2 minus radical 8 over -2 and then 2 plus radical 8 over -2, we'd end up getting these two values. X equals -2.4 or x equals positive 0.4. So those would be our x-intercepts. So a little bit messy once again, but that's okay. And for the y-intercept, evaluate g of 0. So we're going to plug in a 0, and we're going to get negative 0 squared minus 2 times 0 plus 1. First two terms cancel, and we're just left with 1. Let's see how we graph this. So its vertex was negative 1 comma 2. Oops. So the vertex is going to be right here. And the y-intercept was 1, so that's going to be right here. And the x-intercepts are negative 2.4 and 0.4. Negative 2.4 is about right here. 0.4 is about right here. So we connect them. Looks something like that. Opens down, which we knew that it had opened down, has a maximum value, and the axis of symmetry is x equals negative 1. So this is our function g of x. Just always make sure you're putting arrows at the end of these also. Okay, and then for the next one, we have h of x equals negative 3x squared plus 6x minus 8. Okay, so let's do the same thing. So opens up or down. So our a is negative 3. So a is negative, so it opens down. And the vertex is going to be negative b over 2a comma h of that value. So I'm going to cheat a little bit. I'm going to let you guys try to plug that in and make sure you get the right answer. You should be getting 1 comma negative 5 for that vertex if you evaluate negative b over 2a and then plug that back into the function, just for time's sake. Next, for the x-intercepts, we're going to set it equal to 0 once again. So we're going to set that function equal to 0. We get negative 3x squared plus 6x minus 8 equals 0. So maybe this factors, but not even going to bother. Just going to go right to the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4 times 8 times c all over 2a. So if we went ahead and plugged this in, once again, I'll kind of leave this to you guys plugging in these values. Our a is negative 3, our b is 6, and our c is negative 8. We would end up getting negative 6 plus or minus the square root of negative 60 all over negative 6. So we have a square root of a negative here. So once again, that's going to give us imaginary numbers like it did a couple examples ago. So when that happens, there are no x-intercepts. There are imaginary x-intercepts. So there's going to be no x-intercepts when we graph it. And lastly, for the y-intercept, so I'm going through a little bit quicker just because I'm sure this is super repetitive. I just wanted to show a bunch of different cases of what could happen. So we're going to plug in a 0, so it's going to be negative 3 times 0 squared plus 6 times 0 minus 8 gives us a y-intercept of negative 8. So let's plot everything real quick. So there's no x-intercepts. The y-intercept is negative 8. And the vertex was 1, negative 5. 1, 2, 3, 4, 5. And we know that this opens down. So we know that this point, based on symmetry, also has to be on the graph. So I'm just going to connect them. And that's our function h of x. Yep. Okay, so let's do, how many more we got? So I'll do 2 more. I'll do these ones pretty quickly. There's a reason why I have them on here, just because they look a little bit different. We solve them a little bit differently. I'll go through it quickly though. So for the next one, we have f of x equals negative 2 x squared plus 8. So for opens up or down, this one is going to open down because a here is negative 2. And the vertex, so once again, it's in general form, so negative b over 2a, comma, f of whatever that is. So if we went through and we calculated that, we would get a vertex of 0, 8. So I recommend you try that on your own just to make sure you're comfortable with it again. So next for the x-intercepts, set it equal to 0. So negative 2x squared plus 8 equals 0. Okay, so when we are solving this one, I'm sure you can see what's different about it. We're missing in the x term. We can still use the quadratic formula. The b value would just be 0 and plug a 0 in and it would simplify nicely. So instead of doing that, let's just use what's called the square root property. So let's solve for the x squared term first and then square root both sides. So I'm going to subtract 8 on both sides and get negative 2x squared equals negative 8. I'm going to divide both sides by negative 2. Negative 8 over negative 2 is 4. And now I'm going to square root both sides. So we get plus or minus the square root of 4, which is plus or minus 2. So that's going to give us the two x intercepts, negative 2 and positive 2. Lastly, for the y-intercept, f of 0, plug in a 0, negative 2 times 0 squared plus 8 will give us 8. Okay, let's plot these points. So we get two x-intercepts, negative 2, let's keep doing that, negative 2 and positive 2. Our y-intercept was 8, and that was actually our vertex. 0, 8 is our y-intercept, so that's also our vertex. So we know that this opens down, so we can actually see what this looks like probably. So connect them, and something like that, and that is our function, what was it, f of x. Okay, so one more here, and once again, I put this one on here for a reason. So we have g of x equals 5x squared minus 25x. So if we want to see if it opens up or down, you can probably see why I put it on here. So the a value is 5, so a is positive, it opens up. So next for the vertex, negative b over 2a, and then the function g evaluated at that x value to find the y value. So I'm just going to skip doing it once again. So I think for this one we end up getting something a little bit nastier that's actually off the graph a little bit. We end up getting 2.5 comma negative 31.25. Yikes. Let's adjust the graph a little bit. And then for the third one, we are going to do the x-intercept, so we're going to set it equal to 0. So what was this? G of x equals 0. So it's going to be 5x squared minus 25x equals 0. Okay, so now once again, you can probably see why I put this one on here. So it's missing the constant term at the end. So we could use the quadratic formula. The c term would be 0 here because there's no constant. Or we could recognize that there's a GCF of 5x that we can factor out. So if we factor out 5x, we're left with x minus 5. And then we can use that zero product property and say, well, that means either the first factor is equal to 0 or the second one's equal to 0. We solve them separately and we get x equals 0 and x equals 5. And then lastly, for that y-intercept, evaluate g of 0. It's going to be 5 times 0 squared minus 25 times 0. This gives us 0. So that's actually going to be at the origin. Okay, so let's graph this. So it's going to be the y-intercept is right here, which is also the x-intercept, right at the origin. And then another x-intercept at 5. And the vertex was crazy. It was all the way down here. I'm going to pretend like this is a little break in the graph, and that gives us negative 31.25. Okay. So that would make our vertex 2.5 all the way down here. Okay, and then we know that it opens up, so just connect them. Looks pretty crappy, but good enough. Okay, and that's our function. What was this one called? G of x. Okay, so that is graphing the quadratics in standard form and general form. So for the last thing for this section, just going to convert between the two forms. So we'll start with standard form and then we'll convert it to general form right now. So converting from standard to general form is relatively simple. All we have to do is expand it out. So we have to essentially FOIL out the binomial squared term and then combine like terms. So let's see some examples. So for the first one, we have f of x equals 2 times x minus 2 squared plus 3. So we want to write this in general form, so we have to expand it out. So we need to do, I'll do this on the side. We know that x minus 2 squared equals x minus 2 times x minus 2. So if you FOIL this out, you get x squared minus 2x minus 2x plus 4. Combine like terms, and we get x squared minus 4x plus 4. So definitely make sure you're comfortable with distributing. In this case, it's called foiling. So that's going to be 2, and then don't forget parentheses. So that binomial squared term becomes what we just FOILed it out to be. So distribute that 2, we get 2x squared minus 8x plus 8 plus 3. Combine like terms, and this will be our function in general form. So combine those constants at the end, and we get 2x squared minus 8x plus 11. Okay, for the next one, we have g of x is negative x plus 4 squared minus 2. So I'm going to do this one kind of in my head here. So x plus 4 all squared, it's going to be x squared plus 8x plus 16 after we FOILed it out. Distribute the negative, we get negative x squared minus 8x minus 16 minus 2. Combine like terms, we get g of x in general form is going to be negative x squared minus 8x minus 18. And the last one for this one is going to be h of x, which is negative 5, x minus 3 squared plus 20. So once again, FOIL out that x minus 3 squared. That's going to give you x squared minus 6x plus 9. If you have to do that as side work, that's fine. Distribute that negative 5. We get negative 5x squared plus 30x minus 45 plus that 20. Combine like terms, we get h of x in general form is negative 5x squared plus 30x minus 25. Okay, so that's going from standard form to general form, hopefully pretty simple, just foiling and combining like terms pretty much. So going the other way, this is going to look pretty confusing if you haven't done it before, but we'll see that it's actually pretty simple when I do these examples. So converting from general form to standard form, to do this, we have to complete the square. So completing the square just means we're trying to rewrite it. So we can rewrite it as a binomial squared, which will put it into standard form. And for now, we're going to have that the a term be 1 for simplicity. If it wasn't 1, we'd have to pull a little bit of a trick, but for now, we're just going to assume that it's 1. So the steps to complete the square for f of x equals x squared plus bx plus c. We're going to add and subtract b over 2 squared to both sides. So this step is very important because you just have to know that. If you don't know that step, you just pretty much can't do it. So you find that b value on the x coefficient, divide it by 2, and you square it, and you add it and you subtract it. So when you do that, your function's now going to look like this. You're going to have this b over 2 squared being added, and this one being subtracted. So that's how you should write it too. Notice how I kind of wrote the subtracted one at the end with that c term. After that, the reason I did that is because you're going to combine the c minus b over 2 squared. And then that other portion, the x squared plus bx plus b over 2 squared, we completed the square for that, meaning we added the term to it, which allows us to write it as that binomial squared. So we can rewrite x squared plus bx plus b over 2 squared as x plus b over 2 all squared. And if you don't believe me, you can go to that binomial squared term right there, and you can FOIL it out, and you'd end up with x squared plus bx plus b over 2 squared. Okay, so for those of you still with me, the final result is pretty much done. It's going to be f of x equals x plus b over 2 all squared plus whatever that c minus b over 2 squared is going to be. And that's going to be it in standard form. So that probably sounded super confusing if you haven't done it before. So I'll try to kind of simplify it here when we do these examples and not write anything that I don't need to write. Try to make it nice and simple for us. So let's convert the following from general form to standard form. So we have f of x is x squared plus 4x plus 6. So we need to write this in standard form. So remember that b over 2 squared, that's very important. Our b is 4. It's the x coefficient. So that's going to be 4 over 2 squared, which is 2 squared, which is 4. So what we're going to do is we're going to add and subtract that 4 value to this function. So it's going to be x squared plus 4x plus 6. I'm writing it over there for a reason. So we're going to add 4 and subtract 4. Because if we're adding and subtracting 4, we're technically not changing anything, right? It's just 4 minus 4 is 0. But we're rearranging it so we can do this. Okay, so now what we're going to do is recognize that this chunk right here, that can be factored. X squared plus 4x plus 4, two numbers that multiply to 4 that also add to 4, that's 2 and 2. So we can rewrite this as x plus 2 times x plus 2, or x plus 2 squared. And then 6 minus 4 is just 2. And we're done. That's our function in standard form. F of x equals x plus 2 squared plus 2. Okay, so technically you don't have to think about those first 3 terms as factoring. It's always going to be that value right there is your b over 2, which is 2. Okay, so for the next one we have g of x is x squared minus 8x minus 3. So our b here is negative 8. So b over 2 squared, that's negative 8 over 2 squared, negative 4 over 2, or sorry, negative 4 squared, so 16. So we're going to add and subtract 16. So it's going to be x squared minus 8x minus 3. Let's add 16 and subtract 16. So all we have to do is recognize that those first three terms, x squared minus 8x plus 16, you can factor it. Two numbers that multiply to 16 that add to negative 8, negative 4 and negative 4. Or just once again recognize that that value is your b over 2. So it's x minus 4 squared. Once again, it's this value right here. And then negative 3 minus 16 is negative 19. So there we go. That's our g of x in standard form. All right, one more. Get this video under an hour here. Maybe. Nope, just kidding. We have applications. So last one, we have x squared plus 5x minus 1. So it's going to be a b value of 5. So it's 5 over 2 squared. That's 25 over 4. So remember, when you square a quotient, when you square a fraction or raise it to any power, you do it to the numerator and denominator. So we are going to add and subtract 25 over 4 to both to this function. So plus 25 over 4 minus 25 over 4. So this is where it's a little bit harder, because when you try to factor those first three terms here, it's a little bit harder to think of numbers that multiply to 25 over 4 and add to 5. That's why using the shortcut's a lot better. So it's going to be x plus or minus something squared plus or minus something. So the value that we're plugging in here, once again, is just your b over 2 value, which is right here. It's that 5 over 2. So x plus 5 over 2. So it's pretty simple once you know that you have to do that. And then negative 1 minus 25 over 4. You have to get common denominators. You would get minus 29 over 4. And that's your final result here. It kind of looks like an A. Okay, a little bit messier, but hopefully that wasn't too bad. All right, so let's do, what is this, like one more question here, and we'll do an application. So for applications of quadratics, there's tons of applications, obviously, for math. Hopefully you know that by now. So I'm trying to throw in some applications towards the end of some sections. So quadratic applications used for many, many things. The one thing that comes to my mind right away is projectiles. So things that are like thrown or shot into the air are called projectiles, and we can model them using quadratic functions. So if you took something and you threw it, the shape that it would make is similar to a parabola thanks to gravity. So you can model them using quadratic functions. So let's do this first one. So we have a ball is shot into the air from a building, from the edge of a building, and the building is 50 feet above the ground. Its initial velocity is 20 feet per second. So we have this equation that models the flight of the ball. So the equation h of t equals negative 16t squared plus 20t plus 50 can be used to model the height of the ball after t seconds. So t is seconds and h is height. And let's answer these following questions. So let's see, how long does it take for the ball to hit the ground? So for the ball to hit the ground, this is going to look something like this. So if you didn't believe me, you could graph it. So it would look something like that. So this would be our function h of t. So since this x-axis here is time, anything negative we can kind of get rid of, because then we'd be dealing with a negative time. So what we're going to do is just going to erase that. And that would kind of be our function for our proper domain here. So we have a ball, and you can actually kind of see how it looks. You throw the ball up, and then it comes back down thanks to gravity. So it's kind of like it's going through the ground over there when it's crossing the x-axis, so kind of ignore that. Okay, so hit the ground. We have to think about what hit the ground means. Hit the ground means a height of 0. So that's going to be h of t equals 0. So what we're going to do is we are going to set this equal to 0. Negative 16t squared plus 20t plus 50 equals 0. And then we're going to just solve it just like we did. So this time we're going to need the quadratic formula. So it's going to be t instead of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the numbers are a little bit bigger here. So if we plug these values in, so a is negative 16, b is 20, c is 50, we would end up getting, I'm just going to skip plugging it in, hopefully we can do that now, negative 20 plus or minus, we would get a square root of, I believe it's 3600, which is 60, over negative 32. So doing these separately, we want the actual values for it. We would get t equals negative 1.25. So if you did the plus or minus separately, and then or we would get t equals 2.5 seconds. So we get two answers here. We have to think about this kind of conceptually and say, well, what the heck does this mean? Negative 1.25 seconds, that doesn't make too much sense. That was the x-intercept that I crossed off to the left of, that was over here on the x-axis. So I crossed that one off because we said that didn't make sense. So we actually omit this value. So that means our answer is 2.5 seconds. So after 2.5 seconds, the ball hits the ground, which is that x-intercept that we see right over here. Which seems like it makes sense, sure. Okay, second question, what is the maximum height the ball will reach? So the maximum height the ball will reach, this is the vertex. So going back up to this graph, we can see the vertex right up here. So we're looking for that value. So we have to remember, how do we find the vertex? So to find the vertex, this is in general form. It's negative b over 2a comma h of negative b over 2a. So we're looking for the y value here. We don't care about the x value. The x value is time. We're looking for the maximum height, which is the y value. But we have to find the height, or the x value first, rather. Let's do this as side work. So negative b over 2a. Plugging in these values, what was the function? It's going to be negative 20 over 2 times negative 16. Yep. So that's going to be negative 20 over negative 32, which gives us 0.625. So that's the time. So after 0.625 seconds, the ball reaches the maximum height. So now finding what that maximum height is, we're going to plug that in. We know it's going to be greater than 50, because that was the height of the building. So plugging this into the function, which is right up here, that's going to be negative 16 0.625 squared plus 20 times 0.625 and then plus 50. So if we simplified this, making sure order of operations is correct again, we would get 56.25. Okay, so this is going to be our answer. It's going to be a maximum height, which is the y-coordinate of the vertex, of 56.25. I believe it was in feet. And that will be our answer. Make sure it was in feet. Yes. Okay, which makes sense because we started at 50 feet and we threw it, got up another 6.25 feet, and then it started going back down. Okay, so pretty long section, but that is it for chapter 3.1.